for homework today. So the first question there, it asked you to define radioactivity. So that is the spontaneous breaking up of unstable nuclei with the emission of one or more types of radiation. Part 2 then asks you to state what change takes place in the structure of the nucleus when beta decay occurs. Now, I was just looking at some of the homework that you sent me. You need to be careful here, okay? So you need to say that a neutron changes, okay? So you'll say that a neutron changes into a proton and an electron. So say that first, that the neutron changes into a proton and an electron. And then your second sentence will be saying that the electron is emitted, or that the electron flies out of the nucleus, high-speed electron, something like that, emitted from the nucleus anyway, you need to say about the electron. So make sure you say that. The balanced equation for the beta decay of carbon-14. So carbon-14 is radioactive. Now carbon has an atomic number of 6. Now they'll always tell you if it's alpha or beta emission that you're supposed to explain. So this one is beta. So what's beta? High-speed electron, negative charge, no mass. So the mass number is going to stay the same. And what's going to happen to the... Now remember, because the neutron changes into a proton and that the proton stays in the nucleus, then the atomic number is going to increase because you've gained a proton. And so when you look up in your periodic table then and you see what has an atomic number of 7, it's nitrogen. And will you be careful that you write the symbol for the element that you're forming, because I just see a few of you don't seem to be doing that. So make sure you put in nitrogen there when you're finishing your equation, okay? Then finally there they told you that they have a piece of fossilized yew from a tree that was alive 6,000 years ago in Offaly, okay? When a tiny fragment of this tree was analysed, then it was found to contain 1.5 by 10 to the power of 12 carbon 14 atoms. Now, will you be very careful with the terms? So atoms. Now, explain why the fragment of yew must have contained 3 by 10 to the power of 12 carbon 14 atoms 5,730 years ago. Well, that's the half-life, okay? So 5,730 years ago, this tree would have had twice the number of carbon atoms. So then when you multiply that, you're going to get your 3 by 10 to the power of 12 carbon atoms, okay? So because the half-life is 5,730 years, then how many carbon, if you have this now, how many carbon atoms would you have had then? Twice as much, because what has happened in that 5,730 years is half of the radioactive nuclei have decayed, okay? Now, finally, they asked you then, what mass of carbon-14 would this contain? Now, you have, at the moment, you've got atoms, lads, okay? Atoms. And it was before, it was the 5,730 years ago that they want you to do. So it's this number of atoms that you're dealing with. Now, you have atoms here. Always, 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 your first step was to get moles. Now you're saying to yourself, I've got a formula for this, but which formula will you pick? Well, if you have number of atoms, then you divide that number of atoms by 6 by 10 to the 23. All of your formulas for calculating number of moles are at the back of your notebook. So have a look there. What information have I been given? I've been given number of atoms, so divide by 6 by 10 to the 23 to convert to moles. You're getting moles. So that's what you get then for moles. And then what mass, go back and read your question, remember? So you have it in moles now. Go back and read your question. What mass of carbon-14? Now don't be tempted to multiply it by 12. It's carbon-14. So the AR of carbon there is 14. And when you multiply that, you get your answer 7 by 10 to the minus 11 grams. Okay? See, what am I doing? Now, then... So I'll just clear that. So then the next question was question 2. What are isotopes? Well, you know that isotopes are atoms of the same element, but they have different mass numbers because they have different numbers of neutrons. A radioisotope is an isotope that's radioactive, so the isotope has an unstable nucleus. And defining half-life then is the time taken for half of the radioactive nuclei to decay. So that's your half-life. Then they asked you to complete this here, look, for question 2. All right. Now they're telling you that it's alpha, this time, alpha emission. So alpha, we said, was the same thing as a helium nucleus. So it's alpha particles are 2 protons and 2 neutrons. So you have to decrease the mass number by 4. So you're going down to 222 from 226, look. And then what's going to happen to the atomic number? Okay, the atomic number has to decrease by 2. So you're getting 86 there. Now, when you look up on the periodic table, what symbol has an atomic number of 86? It's Rn. So please be careful to write down the symbols. Now, the third part of that then, it told you that the radium-223 undergoes alpha decay, and that you're starting off with a sample of 1 by 10 to the minus 4. Now, this is in moles, okay? This is in moles already. How many of these atoms will remain? Now, they want to know how many atoms will remain once this percentage of the sample has been destroyed. Now, atoms. So if I was you, I would firstly convert moles to atoms. They want how many atoms? How will you do that? Well, 1 mole would have 6 by 10 to the 23. So that many moles multiply. So you're getting this number of atoms. So I'm just changing moles to atoms because they want to know how many atoms. Be careful to read your questions properly. Now, if 87.5% of those atoms are gone, well, 12.5% remains. So if you get 12.5% of that, divide by 100, multiply by 12.5, then you're going to get your answer there of 7.5 by 10 to the 18 atoms left. Or alternatively, of course, you could get 87.5% of this and then subtract from your answer from the 6 by 10 to the 19, so that you see how many atoms you have left, because they want to know what you've left, okay? Now, question 3 then asked you for the beta decay, okay, of this sort of a nucleus like this. Now again, beta is an electron, so nothing happens to the mass number. And what happens to the atomic numbers? It increases by 1 because you're gaining a proton, remember. And when you look up then what has an atomic number of 88, you'll see that it's Ra, okay? And remember to put in the symbol there. Question 4, what changes take place in the nucleus of atom? That's the same as question 1. So remember, you're going to say that neutron changes into a proton and an electron, and the electron is emitted from the nucleus. Question 5 asks you to define radioactivity, same definition. Now, the difference between nuclear and chemical reactions. So if I was, you learned about chemical reactions in second year. So you're talking about electrons being transferred from atoms or electrons being shared. Whereas with nuclear reactions, the changes are taking place in the nucleus, okay? So not involving electrons, changes are taking place in the nucleus. In a chemical reaction, there's no new element formed. In a nuclear reaction, there is a new element formed. No bond breaking or making for nuclear, with chemical, there are bonds broken and bonds formed. So look at page 58 there of your revision book, and you'll see the table there comparing the chemical and nuclear reactions. Now, 2 properties of beta. Now, don't say that it's a high-flying electron coming out of a nucleus. You're going to have to say something like it's negatively charged, okay? It's got negligible mass, okay? It's stopped by 5 millimeters of aluminium, something like that. So it's kind of intermediate penetrating power. But say that it needs 5 millimeters of aluminium to stop it. The last part of that question, then part 4, you're told that caesium, okay, that caesium 137 has a half-life of 30 days. It tells you that at the start, that the half-life is 30 days. And then it says what fraction will be left after 90 days. So if you take day 1, okay, you've got 100% of your sample, okay, day 30, then you've got 50% of your sample, day 60, you've got 25% of your sample, 12.5 and so on. So what happens every 30 days, okay, every 30 days, half of the sample decays. So what fraction is left then at the end of the 90 days? Well, 2 by 2 is 4 and 2 is 8. An eighth is your answer. Okay, so half goes every 30 days. Question, where am I now? Question 6. So question 6 then asks you about iodine. Iodine's atomic number is 53 and it's beta emission, remember, okay? So nothing happens to the mass number, so that stays at 131. But what happens to the atomic number? It's increasing by 1 because it's gaining a proton. And then when you go to your periodic table and look up what is an atomic number of 54, then it's Xe, and then don't forget again to write in the symbol there.